Okay, now we're recording. Okay, so I'm going to put you into breakout groups to talk about this homework assignment you turned in on Friday, some of which I've already graded, and they're looking really good, because I want you to reinforce those ideas for one another, and reminding you that this is to link you to that objective I have in the course, which is for you to understand how to interpret a regression in multiple different scenarios. And so that's why I want you to spend some time doing that today. So I'm going to set a timer for 10 minutes. I'm going to be dropping into your breakout rooms as soon as we get them started. Where are my breakout rooms? Hello. Okay. Go forth. I will see you in a moment. Setting a timer for 10 minutes. Okay, now my dice rolling app to get me in a random room. Seven.
Oh,
Cool.
Yeah.
Yeah.
Hello.
Hello.
Hi, Dr. Logan.
How are you?
Good.
Great.
So Jamie, we were just laughing because Jihan and I actually know each other really well. So
Oh,
we were amazed we got put into the same breakout room, and I was excited.
Yes.
I have had that happen before in lots of things where it's sort of like I'll randomly assign people to groups and then it always ends up being the same three people together. Everyone else
Hey,
shifts around them.
I'll take it.
That's how you know it's random.
And Dr. Logan, I was actually able to answer your questions, I think.
Like these ones on the screen, the share screen
Yes,
thing? Yes.
I think so. I mean, maybe you'll tell me they're wrong, but I was at least able to attempt an answer. Which I was
Well,
excited
now you're
about.
talking, so why don't you tell us what yours? What's your Y and what's your X?
Okay, so for my study, I'm looking at adverse childhood experiences, and the two variables that I looked at are a history of child abuse, or what I called parental abuse, and then the respondents also scored their current state of mental health. So I was looking to see if a history of child abuse predicted a current state of mental health. So I said for my Y variable, that would be the current state of mental health. And then the X variable would be the parental abuse. How am I doing so far?
Yeah, that makes, yep.
Okay.
That makes sense. I'm writing them down.
X and Y. Okay.
And so what's 1 unit of X? What does that mean?
One unit of X, so with parental abuse, 1 unit is that you have a history of child abuse.
Uh-huh.
Yes. Okay.
So it's no versus yes?
Yes, that's correct. Mm-hmm.
Uh-huh. So you have a dichotomous predictor.
Correct.
Awesome. And we're just going to wrap this all up. So what was your B0 for this one?
My B0 was 2.77. And the p-value was 0.0000.
00 question mark. We don't know what comes after that because it's so little.
Yeah.
Got it.
Exactly.
Okay, so what does that mean? What does that number mean?
Well, I was able to write down the number. I didn't say I knew what it meant.
Well, that's the next thing we're going to do.
Okay.
So do you have an idea of what it means?
I don't know that I have a very good idea of what it means. No.
Do either of your colleagues here, Jamie or Jihyun, well, I'm sorry, will you pronounce
Jihyun.
your name? Jihyun.
Yeah.
I'm sorry about that. Jihyun, do you have that? I think yours was dichotomous, wasn't it? Yeah,
Oh,
but
yeah,
bullying
right.
dichotomous was your predictor.
Oh, yeah. So my X variable was grade. So I collected data from fifth and sixth graders of elementary school students. And my Y variable was, it's a weird thing, permissive attitude toward bullying. So the higher the score means that you are more agreeable to your violence, in school violence, bullying. So that means bad.
Right.
Mhm.
Right. Okay, so let's do what does 1 unit then mean for you?
Oh, yes. In this case, 1 unit means 1 grade.
Uh-huh.
So yeah, all of them are fifth or sixth grade. So anyway, yeah, 1 unit means 1 grade.
It's actually a little more specific than that. So 1 unit isn't
Mm,
just 1 grade because your participants are all either fifth graders or sixth graders. If they're fifth
mm,
graders, what does the variable look like? What's their score on this variable?
mm.
Is it stored in your data set as 5 for fifth grade?
Yes.
Okay,
Mm.
got it. And so it's scored as 5 for fifth grade and it's stored as 6 for sixth grade?
Sixth grade, yes.
Okay, got it. So yes, 1 unit is 1 grade. That makes sense. Okay, so what's your B0?
My B0 is 3.349.
Okay, so
So
what does that represent?
yeah, so this means this is y-intercept. So it means when x is 0, that means when students are 0 grade, which is weird, then their permissive attitude toward bullying score will be 3.349.
Yes. Now put a pin in that. Forgive my expression there. Hold on for 1 second. Sarah, I'm going to come back to you.
Okay.
So now use those same words, except not about bullying.
Okay.
Did you hear her conditional statement?
I did. And I'm trying to think of how to do mine. So, okay. So my B0 is 2.77. So that's the y-intercept.
Uh-huh.
Oh my God. So if something, sorry, I didn't get the full sentence. If something is 0, then the y-intercept is 2.77.
Yep.
Well, if what is 0?
If what is 0? If you don't know, I'm going to let, yep.
If
Steven
x
has
is
it.
0.
Correct. Jamie, do you remember what her X is?
Thank you.
I'm trying to remember
Yeah, because
It
I
was
think I can
parental
help
abuse.
her.
parental abuse.
Yeah.
So
Sarah,
what does
I'm
it mean when
sorry.
parental abuse equals 0? What does that mean?
That they do not have a history of child abuse.
Yes.
Okay. All right.
Yes. Say the whole thing. Say it. You got it.
Okay. All right. If x is 0, meaning that they don't have a history of child abuse, then B0 is 2.77, which is the y-intercept.
Yeah, you got it. Yeah, you got it. Uh-huh. Well done. And then the other number you have is B1.
Yes.
But I'm not going to do that yet. Jamie, how did you feel about your
Okay.
y-intercept?
I thought it was fine. I thought it was fine. Do I need to just give a quick overview of my variables?
Yeah, go ahead.
Okay, so I had 2 continuous variables. So negative communication patterns were predicting relational quality and romantic
Oh, yeah.
partnerships.
That's right.
Yeah, and so my y is the intercept, which is y is not the predictor, right? Y is the outcome.
Correct.
So relational quality, and then so obviously the predictor was the negative communication patterns, and so there ended up being a positive negative relationship between the 2 variables.
Well, tell me what your B0 was first.
Oh, like the value or the variable?
The value.
Okay, B0 was negative 0.34.
Yes, I remember this. And that, okay, so that was negative 0.34 was your B0.
Mm-hmm.
And what does that represent?
It represents, doesn't it represent the unit at which, like it means like it goes down that much? Like am I reversing it? Am I getting it wrong?
Uh-huh. Remember what we said? Wait a minute. Okay, so hold on to that.
Okay.
Sarah, you just figured this out. So say the beginning of your sentence.
I don't think I figured it out.
For B0, it
For
means...
B0? Oh, okay, yes. So if X is 0,
Yes.
and for me, X is history of childhood abuse, then B0 or the Y-intercept is 2.77.
Right. So Jamie, when your X is 0, what does that mean?
When X is 0, my Y-intercept is 4.13.
Oh, wait. Okay. So I had your B0 and your B1 backwards.
Okay.
I thought you said B0 was negative 0.34.
Which is the slope, right?
Yes, that's the slope.
Yes, yes. And my B1's 4.13.
Okay, 4.13. So when your X is 0, your predicted Y is 4.13.
Yes.
Okay, does that make sense?
I think it does because so because that indicates pretty high relational quality. And so it would make sense that it would go, like each unit would go down 0.344 with the negative communication patterns.
Yes. So as negative communication patterns goes up,
then relational quality goes down.
Right, that's your B1. That's your slope.
Okay.
And so for Jamie, because your X variable is continuous, so you can go up multiple times. And now both Jihoon and Sarah, they can't go up multiple times. You can only change one unit one time. So your slope value is the difference between your two groups.
Oh.
I like that. Okay, we've got some unassigned participants, so I need to go put them in rooms, and then I think our time is actually up, so.
Thank you.
Thanks for going through this.
Yeah, sure thing. I'm gonna ask, would either of you be comfortable sharing with the group? Any of you? Maybe. You can think about it. I'll call randomly instead.
Okay.
Sounds good.
Sorry to those of you who just got here. Didn't mean to leave you hanging. It just flashed up and told me there were some folks who weren't assigned to a breakout room, so I'm sorry about that. Okay. We have almost everybody back. Let me come back and share the screen again. Okay. So what I'd like for us to do is, do we have any very brave volunteers who would like to go through, have us work out their particular assignment? Because if not, I have a list of very good examples from homeworks.
I can do it.
Okay, who's that?
It's Shantanu.
Hi, Shantanu.
Hey. Okay, I'm gonna do it.
Okay, I'm going to take notes while you talk. Okay,
so I wanted to predict the relationship between collective efficacy, which is the perceived capability to do things as a group, and capability, which is the satisfaction that people have with their educational experiences. And my R squared was 0.3.
Wait. I'm backing you up. Because you said you're going to predict a relationship.
Yes. So my predictor variable is the X, which is collective efficacy. And I'm predicting capability using collective efficacy. So my independent variable is collective efficacy, and my dependent variable is capability.
Okay, got it.
Yes. 1 unit of X means 1 unit on the Likert scale for collective efficacy, which is from 1 to 5. But it's continuous.
Likert, 理科特特的.
Yes, he likes it pronounced Likert.
Oh, Likert, okay.
Believe it or not.
Cool. So that's that. And then my B0 is 0.919. And my B1 is 0.609. And my P 0.6, yeah. And my P values are 0.00 for both.
Okay.
Yeah.
So now I'm going to ask you the hard question.
Yes.
Which is, what does B0 mean?
B0 is your y-intercept, which means the constant tells you that when collective efficacy is 0, that means capability will compute at 0.919. If you look at the significance column, I said it's 0.00. So that means it's significantly different from 0, which means that when there's an increase in 1 unit of collective efficacy, there would be an increase in capability by 0.609 because that is the slope.
Yes.
Yeah.
So I was still typing your answer to the y-intercept question when you switch to the slope, which is fine.
Yeah.
Okay, so this is a nice example of continuous by continuous. Oh my goodness. Okay, so this says when collective efficacy
is 0, increases by 1 unit, there is an increase in capability by 0.609.
Yep, 0.609. That makes a lot of sense. And you told me that's significantly different from 0.
Oh, yes, yeah.
Oh, yes. Okay, so that's a positive relationship between your X and your Y variable. And I want to point out 2 things before I ask for another example. So I'm going to look for a dichotomous predictor next, because this is a continuous predictor. And that is right here, your B0, your y-intercept or your constant is always equal to the value when your predictor is 0. Maybe you can use this 0 as remembering that it's when your X is 0. When X is 0, that's what your Y is expected to be. And the other one is your slope, which in this case is the increase in 1 unit from your predictor and the expected score on your outcome, the expected change in your score on your outcome. Okay, nice job. Thank you so much for sharing. I appreciate it. And now, who's next?
I can share if nobody else wants to.
I'm sure nobody else wants to. Who's that? Michelle?
This is Michelle, yes.
Hi, Michelle. First, tell us a little bit about what you study. Give us like an overview of what these constructs are and what they mean.
Yes, so I'm looking at first generation students in an introductory physics class at OSU. And specifically, I'm going to be looking at my X value is the status, whether they're first generation students or whether they're continuing generation.
Which is which variable?
The X. And then how that, or does that predict their final class grade.
And you converted final class grade, right? So F was 0 points.
E is 0. And A is 11.
Forgot, we don't use F at this institution. Is that
weird.
Right? That's so weird. I've never had to give anyone an F, so I'm not familiar with it, but I have heard. Okay, and A was 11, I think, wasn't it?
Yes.
So that's all of the various scaling points. So that's your continuous outcome.
Yes.
And I
And then-
really liked how you coded your predictor variable, which I'm sorry, I'll hold on that and we'll talk about it in a minute, but go ahead. So we have first generation or no. So what is 1 unit of X?
So 1 unit of X. So I coded first generation 0 and 1. So 0 if they were a continuing generation and 1 if they were first generation.
Yeah. Okay.
Okay, so 1 unit is the change from the generation type, either first generation or continuing generation. Okay, and then what is the value of your y-intercept?
Okay, so my y-intercept value is 8.262.
8.262?
Yes.
62. And on your scale, that was a B, right?
That's a B.
Just to interpret it, to add some interpretation weight. And what does that represent?
Okay, so this represents the average course grade when this X is 0, so the average course grade for the non-first generation students.
Right. I'm going to change that to expected. For, you said, not first generation students.
Yes.
So this is a really key point that I saw a couple of you miss slightly. You were interpreting the number correctly in that it is the average or expected score on Y, but you're forgetting the when X is 0 part. Not everyone is, but I saw several people skipping the when X is 0 part. And it's confusing sometimes to think about this in terms of this is when X is 0 means something different when you have something like Shantu had. Wait, I'm sorry, Shan. I said your name wrong and I'm so sorry. Will you say it for me one more time?
It's Shantanu.
Shantanu. Oh, there's the N.
Yeah,
I have dyslexia, but I'm trying.
Yeah,
Shantanu, thank you.
Yeah.
So with Shantanu, having a 0 value when your X is 0 is just the lowest, a really low score on that particular value. Whereas in your case here, Michelle, you have when X is 0, that is a particular category that this person has fallen into. Okay. So now let's do what B1 was.
My B sub 1 was 6.607, which is either a B minus or a C plus, depending on how you look at it.
And what does that represent?
So this represents the average course grade when X is 1. So this is the expected course grade for the first generation students.
Right. That's not a word. Oh my goodness. Okay, so the difference here being that the X1 in this case is the difference between our two groups. Whereas before it was the 1 unit increase on the Likert scale, which they have the same underlying meaning because what you're doing is in the regression equation, which I'm going to write right here. We have y equals B0, which is 8.262 plus 6.607 times whatever the x value is. So that's our regression equation. And so in our case, you could plug any number into x that you wanted to because the math only does whatever you tell it to do. I could put 100 in here. It just wouldn't mean anything conceptually because we only have two groups. Okay, before I move on from this point, because we're going to just take this idea and we're going to make it a little more complicated today. So before I move on from here, does anyone have any particularly fuzzy interpretations, or I don't like that word fuzzy. Like someone said, who commented this, that it made you think it was warm and fuzzy. Like, this is something I love. If something is feeling really unclear, that was Abby. Thanks, Abby. If something's feeling pretty unclear, I'd like to go over it one more time before we move on to make this more complicated.
Dr. Logan, I don't necessarily have things that are unclear. I just have a question, and
Sure thing.
this probably is best fit, probably privately, but whatever. Is there? Can I change my data set? I'll be honest, like I produce a data set. I'm not currently studying anything, not currently have no research projects in the near future. I'm just trying to, be a PhD student and work full time and not get kicked out of school and lose my job. But in like discovering and going through these two assignments with the data set that I have, I've learned that there's a lot more things out there that I didn't know. And so now I like want to change it and do something that could potentially lead me towards a different path. But I've already done my past two assignments on this current data set. Am I gonna get like in trouble if I decide to change it down the line? Okay.
Not at all. So the reason that I have you do that first assignment is because I think we all underestimate how difficult it is to put your hands on data for the first time and figure out what the heck is in there.
Definitely.
And so for a lot of people, when I assigned just a regression for your first homework assignment, I was getting bombarded with questions of like, oh no, what do I even use? What do these variables mean? I don't know where the data set is. And so I backed that up by adding those extra deadlines in order to make sure that everybody gets familiar with their data. If you are confident and comfortable switching up your data set, anyone here is completely welcome to do that at any time. Now you know what the buy-in is, you know how difficult it is, and you have a data set you can use if nothing else comes through. So yes, you can change your data set. You can change it anytime you want. If you need help finding another data set, just let me know and we can work together to find something else if this isn't working for you. Were those your questions? Yes, I think.
Dr. Logan, could you, I forgot what Shantanu had. Could we go over it for again?
Yes, I can also take and post this. Well, I'll post this video online as well once it downloads and saves. So you'll have it. You mean the continuous example?
Yes, because his is continuous and hers, like Michelle's, is category, right?
Yes. Okay, so here's our continuous example. And the other one was the categorical. Hello, chat.
Dr. Logan, could you maybe explain number 5? I think that's where I'm getting stuck on both sets, the how to interpret the V1.
Sure. So I didn't write the regression equation. So let me take this moment to write the regression equation here. Oh my gosh. Why does Word think it's smarter than me? Okay. Y equals. Yes. Thank you. That is so much easier. Should have just let you share your screen. Okay. So we have Y equals, here's the Y-intercept. You can tell because it's not modified by anything. There's no multiplier. Why is it that every time I'm in this class, my hair does something very odd? It must mean that I mess with it while I'm preparing lectures. Okay, so 0.919 is the Y-intercept. And this one, 0.609 times X, is the slope. So if you look at this equation, there's only one thing that can change. What is the only thing that can change in this equation? There's one variable.
Is it
X?
It's either X or it's Y, but it's one of those two things can change. So I guess that was not fair. There's only one thing that can change on the right side of the equation.
Collective efficacy, yeah.
So you could always say, I want to solve for a particular Y, and you can only do that by changing X. So this 0.609 is never going to change, and this 0.919 is never going to change. And so as I move X, as I change X from 0 to 1 to 2 to 3 to 4, then I'm changing it by 1 unit. And so that's telling me how much I expect y to change when I change this guy by 1 point. If I changed it by 10, I could put a 10 in here. That would make my y be equal to 6.09 plus 0.919. Now that is not a thing I should do because you told us, right, Shantanu, that it goes from 1 to 5 only.
5, yeah, yes.
So I shouldn't plug in 5. That wouldn't make any sense.
Yeah. Or you shouldn't plug in 10, yeah.
Oh, yeah, sorry, I shouldn't plug in 10. That wouldn't make sense. But also, by the way, that means that 0 doesn't make sense.
Yes, because it's, yes, absolutely. Yeah.
So no one will ever have a score of 0.919.
No.
Because there's no one, X will never be 0 because it can't be.
But then can we report it like that?
Yeah.
It's fine, right?
You can report it like that. People do it all the time. Well, the part of your readings for this week's discussion, they're all about, should you do that?
Mm-hmm.
So that's a value statement and a value question that you have to evaluate for yourself. So you can read that and see. Mm-hmm. So does looking at it like this and seeing the equation help you see that it's just the X, it's the only thing that can change because it's the slope of your line. And if you think about it like this, I'm going to do something really, really crazy and try to draw on my screen. Oh my gosh. That is awful. My kid tried to hook up a like second screen and a drawing tablet and I gave up. I couldn't make it work. Oh God. Okay, so I'm going to have 2 axes here. And then we're always trying to create. Hello, there is a little dot. It's a scatter plot. This is a terrible scatter plot. I probably have one somewhere in this PowerPoint presentation, and that would be a much faster way to produce one. Here are some dots. Each of these dots represents a person. It looks a little bit more like a spotted Dalmatian than it does a scatter plot. Are you buying it? Okay, so we're going to pretend that this is our x-axis and it's going to go from 1 to 5. 5. So 1 is the lowest possible score and 5 is the highest possible score. Okay, and on our y variable, Shantanu, is that also a score of 1 to 5?
Yes.
Okay, so that's going to be the same. Hello. So the lowest possible score is a 1 and the highest possible score is a 5. So this person over here, they have like a 5, 5. Does that make sense? This person down here has like a 1, like a 2, 1. So what we are doing with regression is we're creating this line through the scatter plot of points. It's not a very easy to see line, but it's there. And so the slope of this line is basically what you're doing is you're saying, if I have a 1 and I plug a 1 into that equation, what's my expected y? I go up here, I plug this 1 in, and this is going to be 0.919 plus 609 times 1. That'll give me my expected score on my y. So and then every time we go up by 1 more, the slope is increasing. The predicted score is increasing by 0.609. So we're connecting the idea of this equation to the idea of this slope of this line. How's that feel?
That's good. I think seeing the graph really helps.
With two groups, there would only be two dots. Well, there wouldn't be two dots. There would just be a 1 and a 0, or a 1 and a 2. And so there wouldn't be anybody in between. There would just be a bunch of dots over here and a bunch of dots over there. Sometimes those are shown like bar charts of how high one bar is versus how high another bar is. Okay, I'm gonna move on from here. I think you're all great. Thank you for playing that game. So let's talk a little bit about centering. We brought it up last week, and I'm gonna talk about it a little more today. And I'm gonna do it like this, so that it's big. So just like the reading that you had, centering a variable means that you're going to take a constant, or just a constant's confusing because we've used that name to mean something else. You're going to take one value and subtract it from everybody. And that just changes the range of values, and it changes the mean, but it doesn't actually change the unit size or the standard deviation. And we talked about that last week. This is a reminder. You can center continuous variables and you can center categorical variables. Now remember, like we just talked about, because it's a B0 on the intercept, your coefficients are always interpreted when every predictor is 0. Your slopes are predicted there and your intercepts are predicted there. Yes, ma'am. Or yes, Nina.
Cool. Yeah, I was gonna ask, am I the ma'am? Just
Yes.
to make sure. So this might this is also kind of like a personal question, but I think other people might have a similar issue. So I believe that you mean center when like there is a value that can't possibly be had, so you kind of set it so that you're automatically like putting your scores so that they fall in line, or when they're predicting something, they fall in line with the things that it can only be, which is a crude way to explain it. But one of my predictor variables is operating on a scale like the gender role, like conforming scale. And so I'm wondering, technically that has two places where it can't be above or below. Like you can't score below a 1 and you can't score above a 6. Is there a way that you like can mean center it so that you're automatically like forcing it to stay within that range? Or are you better suited to say like, oh, well, you're better off making it so that like you cut it off at the lower value or the higher value? Because I mean, technically you can't get less than a 1, which would mean that you like are crazy unwilling to conform to traditional gender roles. Or like if you were above a 6, like that doesn't mean anything either. It's not like you're uber inclined to conform. So I'm just kind of wondering what you do if you're on a scale.
You're so inclined to conform that you force others around you to conform. Is that how that would work? I'm just kidding.
Sure.
So I think that's a really good question. And no, the way that you interpret these really comes down to you as the researcher. And this is one of the reasons that I had you read the ethics in education, or in statistics readings. Why I had you do those is because I want you always thinking about how the way you interpret things is really, it's reliant on you. So mathematically, the way that I would handle a scale like that is I would pick a point, either 1 or 5 or 6. I think you said 1 to 6, either 1 or 6, and I would center there. Or I would center at the mean, perhaps. And then just make sure that as I'm looking at the relationship, I'm not trying to look outside of those areas.
Okay. Cool.
But yes, so you can center in one or multiple places and run multiple analyses if you want to. But you don't really need to do that yet. You might want to do that later on when we get to moderation and we get to interactions in week like 8. But right now, because our lines are always straight and our our relationship is always the same no matter where you are on the x-axis. The weight is always the same. So the weight's always the same, even if you plug in 100 when that scale only goes 1 to 6. You're still expecting the change to be 0.6 or whatever it is. You're still expecting this change to be the same, whatever that B1 value is.
All right. Okay, thank you so much.
Yeah, so just pick a value, but make it within what you've observed.
Okay.
For centering. So we talked a little bit about centering continuous variables last time, and this time I want us to talk about centering categorical variables because it ties into having nominal variables. So that's what we're going to do today. So when you're centering a categorical variable, it just means that you're taking the categories that you have and you're making one of them 0. Right now, we've talked about dichotomous variables, right? We've talked about someone who has gender coded as male or female. They can plug that in as 1 or 0. Or if you have 2 training programs, A and B, then that's 1 and 0. And so when you're centering a dichotomous variable, it's making sure that your 2 values are 0 and 1, that they're not 1 and 2, or who was in my group earlier who had them coded as 5 and 6? Yes, that's right. So
it was me.
That's
Yeah,
right. So
grade
coded
5
as
and
5
6.
and 6 is not, it's not problematic for your intercept, for your slope, but for your intercept, it doesn't make very much sense, which you interpreted that way as well. Okay, so I'm going to have this imaginary program here. This is some data that I have generated, and we have 2 different training methods to get people to analyze complex data sets in SPSS. So in training method 1, I give everybody a textbook. And in training method 2, I give everybody a textbook, but I also meet with them in a lab setting. And then at the end, I give them a test of SPSS skill. That's my predictor. And my research question is whether my post-test scores are vary by condition. So does one of these 2 groups have a higher post-test score on SPSS skill? And I did not put that data set on Carmen, but I will. Okay, so looking at the data set, it looks like this. Here are my ID variables, and here's the condition variable. And you'll see that right now it's coded as 2 and 1. And we just talked about why that can be problematic. Why is it problematic? Look at me making my own transitions. We'll run a regression and we'll look at it. Okay, so first looking at the R square, remember my predictor is the condition that they're in, whether they got the lab or not. And my outcome is SPSS skill. So the R squared here is what? Type it in the chat. You can say, I know that it's, you can put in the number and what the number means, or you can put the interpretation. Oh no, there. I'm seeing 13%, 13.7% of variance explained. Do you remember variance in what? Yep. Yes, you got it. So we have, yep, so it's 13.7% of the variance in Y, which is the SPSS skills score, is predicted by which group they're in, whether they were in training group A or training group B. Hello. Yes, Jamie.
Yes, so I think I'm trying to wrap my head around doing like how a categorical variable and a continuous variable, you can do that in a regression versus just 2 continuous variables. And so with your previous example about, you know, the 2 groups and the setting, like I guess my question is, I would think like a paired t-test would come to mind in answering that
Mhm.
question. And so I guess I'm just wondering what's the difference between that kind of, like, what were we looking at in the regression that would be different than if we had used like a paired t-test or something?
Absolutely. Now, if you remember from our first class, I talked about how t-test is a subset of regression. Actually, it's a subset of ANOVA, which is a subset of regression. It's just a really specific tool. So regression is like a multi-tool. It can do lots and lots of things. Now, the difference is that for something like this, we can start to add more and more and more predictors, and it can get more complex. Right now, like I said in week 1, is we're starting with simpler concepts that are akin to things you've already done and that you already know. And I'm showing you how you can do them with this other framework. So the numbers are the same. If you go back, I'm going to mute you. If we go back to week 1, I even give you some examples where you have the t-test output and the regression output, so you can compare and see that the numbers are doing similar things. Now, when it comes to actually selecting an analysis to use, I typically will always use regression only because it's the simpler, it will do everything. And so I don't ever have to put any cognitive energy into choosing the analysis because I can do it all with this one tool. So does that start to answer your question, I think?
Yes, that's very helpful. I forgot that t-test falls under regress. Yes, so you answered my question. Thank you.
Welcome. Okay, so now we're back here where we are with final exam score, and we've got whether they were in a group or not. And I want to say that I was very impressed. Everyone that I have read so far interpreted this correctly, that the F test is a test of whether we've decreased the amount of variance, error variance in the model. So well done, everyone, on recognizing that. So nice job. Okay, that's my my indicator here. So we're testing whether it fits significantly better than a grand mean model, and it does not, or the model where we guess the mean for everyone. It does not fit better. And then here's my coefficients box. So interpreting the B0, so that's B when X is 0, it's the mean exam score for someone in condition 0, and that is 3.8. Do I know what condition 0 is? No, I don't, but that's which condition it is. I mean, that's what it means. So, and then what I'm saying here for this coefficient is the move from condition 0 to condition 1 is associated with an increase of 1.6 points on the exam. That is not significantly different from 0. So there's no difference between my two groups. But it doesn't make a lot of sense because condition is never 0. I don't know if you remember, they were coded as 1 and 2. So now I'm going to do, they are not valid because there's no group 0. So let me show you what happens when we center it. We need something to be 0 so that our intercept is interpretable. And then also, we don't know what condition means. It's just kind of obnoxious. And if you remember, the very confusing question I had last on the quiz last week was, what's a better name for my variable? And so what I was getting at is this piece right here. My control group was the no lab group, and my treatment was with lab. So if I have control group coded as 0, and I have the lab group coded as 1, then I'm going to name this variable something about there being a lab. So I'm going to create a new variable. I'm skipping that because you're not going to learn that with me. You're going to learn that with Susan tomorrow. So we're looking at the outcomes here. And if you look here, our R squared hasn't changed. You can see it's still up in the chat that it was 13.7% of the variance in SPSS skills is explained by which group you're in, which training group you're in. That's not changed. It's exactly the same. My F test also hasn't changed. It's exactly the same as it was before. Again, still not significantly decreasing the amount of error variance in the model. Now, what has changed is these scores here. One of these has changed and the other one hasn't. So now interpreting B0, B0 is the expected Y when X is 0. It's the mean final exam score for someone in group 0. And that's 5.4. So our book with lab here is the predictor. And so when book with lab is 0, it means they just got the book. So that's telling us that people who didn't get the lab have a final outcome score of 5.4. Whereas people who did get the lab, that's our slope. Now we're going to move to the slope. They're scoring 1.6 points higher on our outcome, but that number is not significantly different from 0. And if you compare it to the previous one, you'll see that this coefficient is identical because like we talked about before, that slope is the same anywhere you go, whether you're inside or outside the actual observed area, your slope is staying the same at this stage. Okay, so that's what it looks like when we center a dichotomous variable. I promised you last week that I'd show you what it looks like when you recentered and changed things over. Your intercept is moving because you've changed what the meaning of 0 is, but your slope isn't because your slope is always the same. Okay, so that was a plain dichotomous variable. Now, who has predictors with multiple categories? Something like, are you a freshman, sophomore, or junior? Or race, potentially. Something like zip code, or it's like different categories of people or buildings or whatever it is whatever nouns you're studying.
I have age in mine, and it could range from 5 to 19.
That's very continuous. So that's going to keep going up as high up as you go. Who else has an example of a variable to share? What you got, Krista?
I can use major, college.
Yeah, college major, exactly. So that if you have something like, can you give me 3 examples of college majors?
Well, I mean, the way that the data set is, I can, let's say college instead. So you could have the College of Food, Ag, and Environmental Sciences, the College of Education and Human Ecology, or the College of Business.
Awesome. All right, that's a good example of 3 different categories of things. Now, if you just put, well, you can't just include them as on like sort of rated on, never mind. I have actual slides to back me up for this, so I'm going to stop trying to do it winged. Can I get one more example of a category?
I can go. So for mine, I have what skeletal collection I collected data from. So I went to Coimbra, I went to Hammond Todd, and I went to Bath. So I have 3 different places my samples came from.
Cool. Okay, so you have 3 possible samples, and there's no, they're just categories, groups, or sort of locations of collection.
Yeah.
But that might be important for your outcomes. Okay,
Yes.
Perfect. So those are 2 good examples of categories. These are explaining what a nominal or qualitative predictor might be. And I say a qualitative predictor, and I don't mean it like qualitative analysis. I mean like qualities of something are different. The categories are different from one another. They don't represent being more or less. So the way we handle a nominal scale in regression is to create multiple variables for it. So I'll show you what that looks like. So I have a data set that I downloaded from the Pew Research Foundation in 2011. And it's about how Americans use the internet to access the news. And they have a variable, and it's called USR, which stands for, was the responder in an urban area, a suburban area, or a rural area? Which is the worst word to say in the whole world. And I'm about to have to say it 100 times. So it's coded as 0, 1, or 2. Now, if we have a scale like that, you can't just enter it as a regression predictor. Do you know why you can't? I actually meant to ask you and have you answer. You can't enter it as a predictor in regression because it would treat them as ordered categories. Suburban would be treated as one more than urban, and rural would be treated as one more than suburban. And that doesn't make sense. There's no such thing as one more in this scale. So when you have something where going from 2 to 3 or 1 to 2 doesn't mean one more, then that's when you have a nominal scale. Okay, I have 2 people with hands raised. Who do I have? Jamie?
That might have been from my hand up before. Maybe I need to manually lower it. Sorry.
And then Nina?
Again, this might be repetitive, but just checking, this is only because now there are 3 predictors. If there were only 2, you do it the way that we did last time in regression, where you're just comparing like 1 to 0, but this is just because you added 1 additional predictor.
Well, you added, so yes, but.
Or not predictor, but 1 additional like group.
Yes, 1 additional category, right? Because in this case, it's urban, suburban, rural. It's 1 variable right now. It's called USR.
Okay.
But it's coded as 0, 1, 2. And so something else where you might see something like this would be race. You might see it coded as like 1 to 5 for the 5 different options that whoever provided for a race was included. And then that's a case where you wouldn't want to include it as 1 predictor.
But if you were but if you were just comparing urban to suburban, you could do a regression because it would just be 2. And then you could do like 0 and 1 and just say there's a difference when you move from urban to suburban. Or am I misunderstanding? Like
you're right, except, so hold on to that thought because you're really close to right. And I'm about to walk through what I think will answer your question. Like, because you're right, except that then what happens to the people who are coded as rural?
Sorry, my question was if there were only the 2 groups, you could, if you only had urban and suburban, then you could do it the way we did before. Okay.
Yep, exactly. That's exactly right. All right, so we can't just enter it as a regression predictor. So we're going to do something called dummy coding. And they call it dummy coding. I don't know, because it makes you feel dumb when you do it. That's not really why. There's definitely a reason, and I can't remember what it is. All right, so before, when we had dichotomous variables, I encouraged you to code them, to center them so that one group was always coded as 0. Male is 0, female is 1. Now, you don't need a second variable to represent males because male is represented in this instance when female is not 1. Does that make sense? You only need 1 variable to represent 2 categories. And so, as you keep going up, this can extend to an unlimited number of groups. If you have G number of groups, then you will have G minus 1 variables to represent those groups. And so, for example, in our Pew data, we had urban, suburban, and rural. So that's 3. So our G in that case is 3. So we'll need 2 variables to represent all 3 groups. And I'll show you how. In our data set, the outcome of interest is called internet news. And it's the number of different news topics that people look up on the internet in 2011. And there are 13 items they could endorse, whether they look up local news, whether they look up state news, finance, arts news, different topics. All right, so our data set information here, we have the ID. This is USR, that's urban, suburban, or rural. We have what the variable they called sex in 2011, which is 1 for male and 2 for female. We have internet news. That's that scale of internet news I just told you about. And then I also have age. We're going to come back to this data set a few times. That's my son. Okay, age in years is also in this data set. Now, if you look, the predictor is actually stored as letters. Hi. You want to listen to me lecture? Can you sit over here and listen, please? Thank you. Okay, so the urban, suburban, rural variable, it's stored as letters, U, S, or R. So the first thing I did, we're going to deal with them. And we're going to deal with them by recoding them. And I'm going to make 3 new variables. And each one of them is going to be dichotomous. And the first question is, did the respondent endorse the urban variable? Does that make sense? So this question is the person urban or not urban? And in this one, we're going to ask, is the person suburban or not suburban? And the last we'll ask, is the person rural or not rural? Did they endorse this, yes or no? So that's going to give me 3 new variables in my data set. And this is how you code it in SPSS, which you can look at later if you want to. And at the end, it looks something like this. Here it said U, and now U is 1, and S is 0, and R is 0. Okay? Oh, gosh. I'm assuming this case would work if the respondent is only in one category. Yes, this will only work if you have something like this. Remember, we started with a variable called urban, suburban, or rural. So they had to pick one, either U or S or R. You couldn't pick all 3. So that's what these variables represent. Hello. When U is 1, it means the participant lives in an urban area. But look at here. If S is 0 and R is 0, we know that U is 1. You see that? If U is 0 and R is 0, then S has to be 1. So just like before, when you only needed one variable to represent male versus female, now you only need 2 variables to represent urban, suburban, or rural. So there's 2 ways to represent urban. It's either when U equals 1 or when S and R are 0. All right, so if we're going to look and see whether internet news is going to vary by urbanicity, which is whether they're urban, suburban, or rural. So first I have some descriptive information, and you'll see that I have 447 people who are not rural. Wait, sorry, 447 people who are rural, and 1812 who are not. My mean score on internet news is 5, with a range from 0 to 12. So I'm going to put that into a regression. And here, the first thing I see is my R squared. I just have one variable in the model right now. That's rural versus not rural. I have one variable in. So being rural is explaining almost no variance in my internet news scale. My F test is significant, so I have significantly decreased the error in my model. Here is my, my outcome, my constant, which is when R is 0, which means when people are not rural, their mean internet news score was 5.2. When they are rural, it goes down by 0.881, which is significantly different from 0, which is what these have. Okay, so far, this is just like any other dichotomous predictor we've used. No different. Now, here's where it's going to get different. We are going to put, remember we need G-1 groups. With 3 groups, we only need 2 predictors. We can't use 3 because then the third one would be perfectly predicted from the other 2. So we can only put in 2 at once. So we're going to pick 2 variables. If I put in suburban and rural as my predictors, everybody get ready to your chat. If suburban and rural are in the model, what is my 0 going to represent? Yes, yes, yes. When suburban is 0 and rural is 0, the only thing left is urban. That means that my y-intercept, my constant, is going to be all about the urbanites. Okay, suburban equals 1, the person lives suburban. When rural equals 1, the person lives in a, wow, that is not right. when rural equals 1, the person lives in a rural area. So I apologize for that. That's very confusing. This is me reminding you how it works, but you clearly got it. So I'm going to move on. So U is defined when the other ones are 0. And if you remember what else is defined when everything is in 0, it's the intercept. My dance moves don't show. Oh. All right, so the intercept is taking on the role of representing the group that doesn't get its own predictor in this case. All right, now let's look at what this looks like. The way that you do it is with something called a multiple regression. So it's a multiple regression because we're going to include multiple predictors. We're only going to use 2 of the variables we just created, and the one you don't pick becomes the reference group because the reference group is the outcome. So we're using urban as the reference group, which means S and R are going to be our predictors in the model. Here's our output. Our R squared has not changed. It's still 0.7%. But you'll look down here as a little bonus. You can see, I don't know why it says W, it should say S. You've got 2 predictors here, R and S. These 2 variables together are explaining this much of the variance. Here's our F test. We've still significantly decreased the error in our model. Now let's look at the output. Now this is new. Before we only had 1 line, now we get 2. So let's talk about these. Now we already know what the intercept is going to be because you all so eloquently put it up here. It's for urban responders. Urban responders, their mean score on internet news is 5.3. Now what this represents, the 0.08. Oh God, yes. For S, this is the 0.08. The slope associated with being in a suburban is the difference between S and whatever's coded as 0. Because we're controlling for the fact that we have rural in the model. So this is the contrast between suburban and urban. So this is telling me that the difference between the suburban group and the urban group is negative 0.08, which is not significantly different from 0. Suburban responders are not significantly different from urban responders in their internet news use. Rural is just ignored in this contrast because it's in the model, but we're not talking about it right now. We're only contrasting suburban and urban. So by that logic, let's talk about R. So this is the expected difference in internet news scores for someone in the R group, the rural group, compared to someone in the urban group. And we're ignoring suburban. We're controlling for suburban. So it's just the other 2 that we're worrying about right now. So this is telling me that rural responders get significantly fewer topics of internet news online compared to urban responders. They get almost 1 whole topic less, which is significantly different from 0. Do we know, here's a question I have for you now. Is the suburban group different than the urban group? Give me a chat. I see a lot of no's and not significantly. And how do you know? What's the indicator that tells you? Yes, I see P is greater than 0.05, or this P value here is 0.701. So that P value being greater than 0.05 is telling me that the suburban group is not different than the urban group. Is that because y'all have the slides and you can just download them? Just kidding. All right, now how about the rural group? Is the rural, damn it. Sorry, is the rural group different than the urban group? Yes. And I'm going to assume that you know for the same reason, because that p-value is less than 0.05, it's very small. The rural group is one fewer news topic than the urban group. Now, what about this? Oh, let's look at the regression equation. Now, remember, before we only had one x value. Now we have two x values. They're just, in this case, they're called S and R. So we have the predicted y is equal to the y-intercept plus this negative coefficient associated with being a suburban responder, and then plus this other negative coefficient times the rural responder. Okay, so that's our regression equation. We pull all three of these things down, and we're going to use the same principles we used when we had only one x, but now we have two x's. So that's our regression equation. So if we want a mean score for somebody who's suburban, we would plug in a 1 here. And we would plug in a 0 here to get our expected score, which looks like this. 0.80 times 1, 0.93 times 0. Just like we did before, except that we have one more ball in the air. It's like before we were juggling with just one, just like two balls in one hand, and now we have a third one. There's a third thing to think about, which is another slope. So that gets us our y hat. If you calculate it out, you can get the expected score from each group, but I'm not going to do that because I forgot how long this takes and I want to do other things with you today. Look at how fun that is. You can get the predicted score for each one when you plug in 1s and 0s that correspond to each thing. That's the initial equation. Okay, now here's the actual mean scores that I show you to demonstrate that our predicted scores are pretty close to the actual mean scores. Da-da-da-da. Now, what if you want to compare two groups that aren't the reference group? Because you might notice that one thing we haven't done yet when we look at this, can you tell me, is suburban different than rural? You can't, because there's no test of that. There's no way to compare S versus R. We don't have a significance test of that contrast here. Everything is being compared to that constant. So you can change up your reference group or pick a different reference group. And yes, you can use the same strategy for as many nominal groups as you want. Yeah, as many as you want. 4 is fine, 5 also fine. I will tell you, once you get past about 7, I just find it very hard to keep track of it, but you can, if you want to try it, go for it. Okay. Now, now here we go. Now we're going to work on this quiz. So I want you to work alone first. I'm going to set a timer again for about 7 minutes for you to work alone through the following questions. Use a scrap piece of paper. Okay, I actually said you're going to have 5 minutes to work alone and then 10 minutes to discuss in groups afterwards. And you're going to go back to your same groups you were in before. All right. If you have clarifying questions about this, send them to me in the chat. Here are your 4 questions. It's based on the same thing. What I've done is I've changed, instead of it being predicted by urban and suburban, or rural and suburban, I've chosen different predictors, but everything else about this is the same. Okay, timer 5 minutes starting now. Okay. 6.
Percent.
Yeah.
The same as what it was before.
Mhm.
Hello.
Hello.
You are my randomly selected room. So
Right.
keep going. Looks like are you on number 2?
We were just discussing the first one. We were there.
Great.
So I had said it's 0.7%, and that's the same as what it was before. That didn't change.
Mm-hmm.
Mm-hmm. And for the question 2, I think they are significantly different. B equals to 0.951 and P is 0.0. It is less than 0.1101.
Mm-hmm.
Yep. Does that make sense?
Yes.
Yep. Urban's different than rural. And what about the suburban group? Is it different than the rural group?
And I think they are significantly different from each other, and the B value is suburban, and the B value is 0.814.
Mm-hmm.
Yeah, same as mine.
And then for the last question, I had said you don't know it with this comparison because of you're comparing both of them to rural, so you can't compare them between each other in this model.
That's right. You're exactly right. You can't.
Got it.
Yeah. So I think I said that in passing when I was explaining the last model, but that's exactly right. You can't compare them in this model. But I am going to back you up really quickly and ask if you will interpret for me the number 2. So I see it's a difference. You said, yes, the urban group is different than the rural group. And you said by 0.951. What does that mean, 0.951?
It means, it means when the student is from, when the city is like rural area, and I'm mixed with the 3 categories.
I know.
I mean, when the category is urban, and the internet, what's the question? Yeah.
Anybody want to help her out? So
So it would be the 0.951. So if they're from a urban area, they get that one. So almost one more internet news article compared to someone from a rural area.
That's exactly right. Yep, you got it. Well, this ended up being, you guys got it. Why don't you chat for 2 more minutes, and then I might pull people back early depending on how my next random room goes.
Okay, thank you.
Okay, yeah, bye. Maybe.
So then how do we do that?
We can't. Not on this one. You'd have to recode it.
You got it.
Yay.
Oh my God, I was so worried that I got that wrong. I was like, is this a trick question?
No, you can't do it.
You can't do it. It is kind of a trick question, although I did say it.
Right. Yeah.
You did say it.
That's the only reason I got it right is because you told us previously.
Yeah, it's you have the answer to that on a previous slide, but you don't have it here on this one.
Yes.
So it was only mildly stressful?
Yeah, I thought it was pretty good.
It wasn't stressful. It was like,
awesome.
I think this is right.
Okay, awesome. I feel like maybe this went better than I expected and I can pull everybody back sooner. You're the second room I've been to that seemed you got it. Did it feel good? You got the other 2?
Yes.
I think so.
Sweet. Okay, I'm going to go visit another room.
Thanks for visiting.
Thank you.
Whoops. Uh-oh, hold on. Okay.
Of anatomy. It's a mouthful.
Hello.
Okay. Hello.
Did y'all?
We finished.
Just finished? Oh, so smart. I should have said when you're done, come back. That was a really smart idea, and I'm going to start saying that because I feel like I've visited 2 rooms and both of them were like, yeah, this is fine.
Yeah.
Does it feel fine?
We had a question confirming number 4, but I think you'll get to it, I think, in review of this. So we'll hold off until we get there, I guess.
All righty.
Cool.
I'm going to just bring everybody back a little bit early. Oh my goodness. Dun, 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 dun. Hi. Is everybody back? All righty. Okay. Sounds like that one went pretty well. I visited 3 rooms and everybody felt like they had it pretty clearly. So let's talk about the, oh, not everybody's back. I'm sorry. I thought everybody was. Okay. Let's talk about how this felt. How was number 1? Give me a okay or a help. Meh. I get a lot of thumbs up. So the amount of variance explained by our groups was 0.07, which is exactly the same as it was before. Thank you. Okay, how about number 2? Did you get that one? Feel pretty good about that? So that's a yes. The urban group is different from the rural group, and I get that from here. The coefficient is 0.951. That's urban different than rural because the other 2 are.
I think there's a
here.
chance you forgot to share your screen again, so I don't know if you're pointing at stuff.
Bless you.
Sorry.
Please do not apologize. You definitely shouldn't apologize. You're like, what are you pointing at? Okay, number 2, urban different than the rural group. Yes, based on this 0.95. And then the suburban group is different than the rural group. We can get that here from the S coefficient. Now this one here might have felt a little bit tricky. The difference between the urban group and the suburban group, you do not have access to in this contrast. You cannot get it. And I think it was Patrick maybe who asked me right before we closed the breakout rooms and said, does that mean we need to run it multiple times if we want to do all the contrasts? And the answer is yes. If you want to get all 3 contrasts, you would have to run this 2 times. Who's got Nina? Yeah.
Why would we have to run it 2 times? Like,
if you wanted to see the contrast between urban and suburban, and you want the contrast between rural and urban and rural and suburban, so you want to compare all 3 groups to one another, then you can't do that in 1 regression model. You would have to do that in 2 regression models, which is this one. I'm going back, I'm sorry. Oh gosh, I should have put them both together. So here's the first one where we compared suburban to urban and rural to urban. So you'll see here that suburban and urban are not different.
is this when we put values differently to see how they are and then we match them? I mean,
how we put values different. Well, you can
SPSS, like while putting it.
You just choose different predictors for this particular way to go about it. But I think, let me rephrase, which is what I would rather you do and what is better science practice is to pick one that you think should be the constant, one that you want to compare the others to, and run it 1 time, and then you'll have those contrasts. And you don't get the other one, but you will get the first 2. So you get urban versus rural, and you get suburban versus rural. All right, so that's our 4 questions here. Who else? Nina, I think you had your hand raised.
Yeah, I was wondering, I asked my breakout group this, but I just want to make sure. So you say, is the urban group different from the rural group? If so, by how much? When you ask, is the urban group different from the rural group, are you saying, is it significantly different? And that's when you would say, that's when like how different it is matters? Or would, even if these were wildly insignificant, would you say like, you can still say how much they're different, it's just not significant? Does that make sense?
It does make sense. So I think what science sort of has coalesced around, the social sciences have coalesced around this idea of p less than 0.05 for better or worse. And so you can say, like for example, the other one we saw, they were different by like 0.08. And so you could say they are different by 0.08, or we estimate that it will be 0.95 different, but that's not significantly different from 0. So there's no relationship. So you can interpret the coefficient as the estimated difference, but then say, however, that number is not significantly different from 0. Does that clarify? So yes, say both.
Yeah. Okay, thank you.
Yeah. Okay, so let me see here. Okay, well, I have done a terrible job managing time because I really wanted to make sure we got that first bit down. So hang on one second. We're reviewing. I'm clearly not going to finish all of this in the next 15 minutes.